Here's a warm-up. Use the left and right room sum to approximate the integral. We have this integral and we have this table. So given that we're not given how wide they want each rectangle to be, I'm assuming that we're going to create 1, 2, 3, 4 intervals. So the way this works is, I'll pause the video and you guys are gonna give it a try first. All right, and then we do the same thing with this one. It's from 0 to 4. Again, it's not given to us how many ends they want. Yeah, it's not told. We're not being told. All right, so for this one, let's go ahead and do the standard. We want a separation of 0.5. Oops, that is way too large. We want a separation of 0.5. I would like that to be my delta x. So let's go ahead and say that n equals 8. Alrighty, that being said, I'm going to pause the video. I'm not going to pause the video. You will pause the video. You pause the video, give it a try, and then you see what I did. Alright, I just made a realization right here. Notice that the distance between here and here is 2, and then the distance between here and here is 3, and then the distance between here and here is 2 again, and then from here to here is 3 again. We can still do a Riemann sum. The only issue is we won't exactly get a nice shortcut. So what I will do is the distance between here and here is 2. So I'm going to go do this one, make a shortcut for that, and I do a shortcut for this one, and then for this one and this one, I shall do a different shortcut where the width is 3. I don't like to do stuff like that, but it's not really much we can do. So there will be 2 times, and then we want the left for first. So that will be this value. So 2 plus, and then the left would be this value, 5. And let's just do the right one too while we add it. So for the right one, I'll just indicate it with doing it in black. So that'll be 2 times, and then in this case, it will be 3 and 7. 3 plus 7. So that's my right, and let me now do my, so this one will be my left, and that's for, I'm going to combine that with my other shortcut. So my other shortcut's going to be this one and this one together because they're 3. So 3 times, and the left would be, it would be 3. And then, because that's the left from right here. And left for this guy would be 7, so plus 7. So I'm going to combine these together, if that makes sense. And let me go ahead and do the right for, let me do the right one as well, real quick. I'm just going to keep it black for the right one. So I did, I already did this one, and I did this one. Now it's time to do this one and this one. So that'll be, what did I do? 3, and then, why did I just do this? Now I have to think about it. Alrighty, just to go over it, totally, no, I did the right thing, but when I marked the blacks right here, then the black lines, I messed up my thought process. So, my right ones, I did the 2, and then my right one's going to do a 5, and then my right one's going to do a 7, and my right one's going to do a 10. So essentially I'm going to be doing 10. So the last one's going to be 10. And the distance between here is, so that'll be 5. Okay, there we go. Finished. And I should have changed the color, so that's, can't really change it. Alright, I did it the worst possible way. Trying to do the right and the left at the same time was a big mistake on my part. I think I did it right, but you will, of course, you will tell me if I did right or wrong. So this right here gives me a 714. This right here will give me a 30. So 30 plus 14 would be 44. So the first one would be 44. And then, I don't know what to write it. Okay, 44. And then the second one would be, this one right here would be 20. And then this one right here would be 1545. So the other one, the right one, ended up giving you 65. Not right like correct, but like this is the left and that's the right. The right was like way larger than the other one. Alrighty, so this was the worst mistake of my life, and I've made many. Just making sure I did it correctly. This gave me 7, and that gives me 10, so I expect that to be lower. Okay, this is 10, that's 15, so I expect that to be. So the right one's gonna be way larger. I was a little worried because the right and the left were like very different from one another, but I did it correctly, I believe. Alrighty, so let's do it the rational way. To do this one, again, the width will be 0.5, and then we want to do. Are we asked to do the left and the right? Okay, I will not separate them. I will not do them at once this time around, because I only make mistakes one time. That's what I like to think. You know what I mean? It's make a mistake, shame on me. Make a mistake twice, I think still a shameful thing to do. Alrighty, is that all I have to do? Alright, let's check. For the left one, we're gonna definitely be using 0. Does it start from 0? I don't know. It starts from 0 to 4. So we'll be using 0, we'll be using 0.5, we'll be using 1, we'll be using 1.5, we'll be using 2, we'll be using 2.5. Oh, I'm way off. I need way more than that. And then I need 3, and I need 3.5. Because for the left one, the only thing I'm not going to have would be the 4. You know what I mean? Alrighty, I'm very comfortable with this, but I will barely care. Alrighty. Pause the video so I can get the values. But before I get the values, I just want to. I thought this was worth mentioning. If you're wondering if you did this correct, because I know that this can, there's a lot of room to make mistakes. We start out with wanting to have 8 rectangles, right? Because I tried to have a separation of 0.5. So let's see if I'm going to get it. So the width of a rectangle times the first one, the width of a rectangle times the second one, the width of a rectangle times the third one, the width of a rectangle times the fourth one, blah, 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 fifth, sixth, seventh, and eighth. We are going to get n equals 8 rectangles. So kind of made myself a little legend right here, giving me all the values. You notice that there are 9 right there. That's because it includes the left and the right values I would need. So for the left one, we pretty much do from here all the way down to right there without using the last one. So this is what we get. We're going to add that together and get a value. For the right one, we would skip the first one and go all the way down to this one, and that will be your right value. We're going to get that as well. So let's do that. Alrighty, I've just done the math, so you should end up with 32.500 and 28.500. So this would have been your left one, and that's your right Riemann sum. Does that conclude this problem? It sure does. Yep, that's it. Alrighty. And again, this was just a suggestion. You know, you could have probably just done delta x equals 1, but I just kind of went far, I guess. Alright, so this is the part 2 of the same lesson, so you're probably familiar with the objective. Students will apply the fundamental theory of calculus to evaluate definite integrals. So let's get this one started. Alright, right now we want to evaluate the cosine of x, starting from pi over 3 all the way to 0. That's a weird way to put it, given that 0 is the upper limit, and then the lower limit is pi over 3. Kind of like going backwards. So you see how over here we have pi over 3, and then we have an arrow pointing that we're going actually go in this direction. So let's do it. The integral of cosine is sine. I know that because the derivative of sine is cosine. We want to first plug in the 0, so sine of 0 would give you 0. Then plug in pi over 3, that will give you square root of 3 over 2. And then subtract the 2, which would give you negative square root of 3 over 2. if you were to put the integral from 0 to pi over 3, like the way that usually it is, traditionally, you would have gotten the same answer except with a positive, because this one and this one would have been in reverse. Alright, let's move on. Alrighty, here's another one. We have the, let's see, sum the integral of the same integrate. Find the area underneath the curve. Alrighty, so that would be right here. Area underneath the curve, you have a triangle right there. We have another triangle right here. The other triangle is right there. So let's do the area of the first one. 1/2 base, which would be 5 times height, which would be 6, plus 1/2 base times height, which would be -4. Remember that areas underneath the x-axis will be negative. Add the two, you would end up getting 5. So, not too much. I mean, this example problem would be a lot easier. I mean, a lot harder if they would have given you equations instead of like a easy geometrically known thing. Anyways, doesn't matter. Let's move on. Alrighty. Now we have the integral of the cosine, which we know is sine, but we start from -pi over 3 to pi over 3. That's more something I'm used to, because that is furthest to the left and that would be furthest to the right. So essentially, we're going to go ahead and do this. And now they did this. I mean, they had to, because if you were to do it the other way around, you would have gotten the wrong thing. Here's what I mean. If you would have done -pi over 3 to pi over 3, instead of doing just like 2 times 0 to pi over 3, you would have gotten the wrong answer technically, because you would have probably gotten a 0. But given that you know that there's symmetry in cosine, you see that there's symmetry, whenever you notice that you get a 0, but you know that there's actually an area, you probably want to ask yourself, why did I get the 0? And then you say, oh, because I did sine of pi over 3, and then minus, and then sine of -pi over 3, and that gave me, would that have given you 0? Sine of -pi over 3 would be the negative. Actually, they didn't need to do this. They totally did not need to do this. They could have just put -pi over 3. Okay, I digress. But just to reiterate, sometimes you're being put in a situation where you do like one minus the other, and because they're the same, they would have given you 0. And then you think to yourself, but it shouldn't be 0, because this wasn't, I mean, there's an area. So in this case, you cut it in half if there's symmetry. In this case, there's symmetry. And then just do from midpoint to one end, just multiply by 2, and you're done with it. But in this case, they didn't need to do this. They could have easily just said sine of x from -pi over 3 to pi over 3. Because as far as I know, sine of -pi over 3 is the same thing as negative sine of pi over 3. So if you were to actually put this in practice, you would have put sine of pi over 3 minus and then negative sine of pi over 3, which would have given you 2 times sine of pi over 3. They could have just left it the way it is. I really don't understand why they decided to go from 0 to pi over 3 if it could have easily gone from -pi over 3 to pi over 3. I digress. I mean, the answer is going to be still the same. I just don't know why they did this. They are unnecessarily confusing students, but I'm just going to move on. Maybe they thought it was going to be 0. Maybe they were worried about it. They probably thought that if they would have put -pi over 3 here and positive pi over 3, that it would have ended up giving you 0. They probably didn't notice that they would have gotten a positive, like it's going to be twice this. But who knows? Alrighty, so please do these problems. You have 1, 2, 3, 4, 5, 6 problems, and they're all relatively easy. This one might be a little bit tough. Let me just do this one real quick. So to do this, we do a u substitution because we don't like this inside. So u equals 2x plus 10. du equals, come on, 2 dx. And we don't have a 2, so let's put a 1/2 on the outside. And let's put a 1/2 right here, and let's put like a 2 right there. So, by the way, that 2 I would have preferred it to be right there. So we would have ended up with 1/2 -3 of square root of u du. Yeah, that's good. All right. So let's do the integral. 2/3 u of 3/2. And then plug in the stuff, 2/3, and then 2x plus 10 to the 3/2, and multiply it by 1/2. So this becomes a 6. Alrighty. We're going to do that from -3 to 3. So plug in 3 here first, see what you get, then plug in the -3, see what you get. I'm going to pause the video and then we can compare. So I did the math just now, so I ended up with this and this, but then I did not subtract those properly, so I just changed it to 21 to 1/3 and 2 and 2/3 because I know that that is 1/3 and 2/3. And then when I subtract, I know how to deal with that. I ended up with this. So that's my value. Alrighty. I see you guys tomorrow.